Concrete is the world's most heavily consumed material. 8 billion cubic metres of concrete are poured each year. That's equivalent to more than 1 cubic metre per person on the planet every year. Concrete is made from 3 principal ingredients, from cement, aggregate and water. And those materials are mixed together to produce a liquid that can be poured into almost any shape and with time turns into a rock-like material. It can be poured into any shape. So depending on the mixture of cement, aggregate and water we use, we can produce materials with very different properties. Concrete is usually strong in compression and stiff, but it's weak in tension, and we can get over that by reinforcing it, usually with steel, to produce a material that is both strong in compression and tension.
What is aggregate?
Well, aggregate is one of the 3 principal ingredients of concrete. It comes in different sizes and starting from sand and moving up to larger particles. And these particles fit together to produce a dense material. So in concrete, these pieces of aggregate are bound together by a mixture of cement and water to produce a material that is initially moldable and with time develops strength and becomes stiff.
What is cement?
Well, cement is the second principal ingredient of concrete. There are many types of cement. The one we use most widely is called ordinary Portland cement. The way that's made is to take 3 portions of limestone and 1 of clay, heat them to 1500 degrees centigrade in a kiln, grind that material down to a powder, the powder that we call cement. So if we take cement and mix it with water, we form a paste. And within the paste, chemical reactions occur. We call those hydration. And those result in the paste turning from a liquid into a solid material.
So what's the point of the aggregate?
That's a good question. The cement paste acts as a glue to hold the particles of aggregate together. Aggregate's just as strong as cement paste and is far less expensive, and so we use concrete rather than cement paste on its own. There are other reasons too why we don't use cement paste in construction. Cement paste expands and contracts as it heats and cools. It also expands and contracts as it wets and dries. The aggregate, which is more stable, reduces these effects. Well, concrete reaches its initial strength very quickly. Here's a concrete cube that I cast 24 hours ago, and it's already hard to the touch. If I were to look at this in the microscope, then I'd see that the cement and water had already reacted together to produce hydration products, and it was those that were holding the particles of aggregate in the concrete together. After 3 days, the concrete would have reached a strength typically of 50% of its long-term strength. And the concrete continues to gain strength as the cement and water react together, but it does so at an increasingly slow rate because the individual particles of cement are now protected by the hydration products that are formed, and so it's more difficult for water and cement to come together to react. In construction, we usually assume that concrete has reached its full strength or something very close to it after 28 days.